Okay, let's dive into this. You know that feeling, right? You're building something, and you're so close to being done, but one little piece is just off. It's not quite right. That tiny, frustrating gap between almost and perfect, that's what we're going to tackle today. We're going way beyond your standard ruler and into the world of real precision. I mean, think about it. You grab a ruler to measure something small, and the edge lands somewhere between the little millimeter marks. Is it, I don't know, 3.4 millimeters, 3.6? For a bookshelf, who cares, right? But if you're an engineer or a scientist or anyone who needs things to be exact, well, guessing just doesn't cut it. So yeah, for those times when good enough is absolutely not good enough, we have to upgrade the toolkit. We need a way to see into those tiny spaces between the lines on the ruler. See, every measuring tool has a fundamental limit, and for most rulers, that's 1 millimeter. There's actually a technical term for this. It's called the least count. It's basically the smallest thing a tool can accurately measure. Anything smaller than that is just a guess. Now, you're going to want to hang on to that term, least count, because it is the secret to this whole thing. So, the big question is, how do we get past that 1 millimeter wall? How can we confidently measure those tiny little fractions? Well, we need a smarter instrument, and lucky for us, someone already invented one. And here it is, the star of the show, the hero of our story, the Vernier Caliper. This thing is how we solve our precision problem, and honestly, its design is just pure genius. At first glance, it might look a little complicated, but it's really just two main parts. You've got the big, fixed scale, the main scale, which is basically just a high-quality ruler. And then you have the smaller scale that slides along it, and that's called the vernier scale. The magic, the real secret sauce, is in how these two scales play together. And this thing is a total workhorse. See those big jaws at the bottom? You use those to measure the outside of something, like the diameter of a pipe. The smaller jaws up top, they do the opposite, for measuring inner dimensions. And that little metal rod that sticks out the end when you slide it, that's for measuring depth. It's basically 3 precision tools all rolled into one. So how on earth does it work? How does it get so incredibly precise? Well, it all comes back to that concept we just talked about, least count. But the way the Vernier Caliper uses it, well, that's where the genius comes in. So, quick recap. The least count is the absolute smallest thing an instrument can measure. A good Vernier caliper can often get down to something like 0.02 millimeters. That's incredibly small. The real question is, how does it do that? Okay, here's the trick. It's all based on a very small, very deliberate mismatch. The markings on that sliding Vernier scale are designed to be just a tiny bit smaller, a little more squished together than the markings on the main scale. And that tiny little difference, that's everything. So, for example, a single marking on the main scale might be exactly 1 millimeter, but a marking on the Vernier scale might be just a bit shorter, maybe 0.9 millimeters. It's that tiny 0.1 millimeter difference that we're about to use to unlock a whole new dimension of precision. And here it is, the formula that puts it all together. The least count is simply the length of one main scale division minus the length of one Vernier scale division. That little gap, that tiny leftover amount, is the resolution of the tool. It's the smallest distance it can possibly see. All right, enough with the theory. It's cool, I know, but let's get practical. Now that we get the principle behind it, how do we actually take a measurement with this thing? It's actually a really simple 3-step process, so don't be intimidated. First, we're going to get our main reading. Second, we find the one magic line on the Vernier scale that lines up perfectly with a line on the main scale. And third, we just do a little bit of super simple math to get our final ultra-precise number. So here's how we calculate it. First, you look at the 0 on the sliding Vernier scale. The last full millimeter mark you see on the main scale before that 0, that's your main scale reading, or MSR. Then, you carefully look along the Vernier scale until you find the one line that aligns perfectly with a line above it. That number is your N. You just multiply that N by the least count, add it to your main scale reading, and boom, you've got your measurement. Okay, so you've got the basics down, you're ready to level up. In a perfect world, every single tool would be perfectly calibrated right out of the box. But we don't live in a perfect world, so we have to talk about something called zero error. So what is zero error? Well, it's what happens when you close the caliper's jaws completely tight. The reading should be exactly 0, right? But sometimes, the 0 mark on the Vernier scale doesn't line up perfectly with the 0 on the main scale. That tiny initial offset is the zero error, and we have to account for it to be truly accurate. Now, there are two types of this error. If the vernier 0 is slightly to the right of the main scale 0, we call that a positive error. If it's to the left, you guessed it, it's a negative error. You can see exactly what that looks like right here. And here is the absolute golden rule. You gotta remember this. You always subtract the 0 error from whatever reading you take. This simple step is how we cancel out that initial mistake and get back to the true correct measurement. Now, this is where it gets a little fun, a little counterintuitive. If you subtract a positive error, your final number gets smaller. That makes sense. But what happens if your error is negative? Well, when you subtract a negative number, the two negatives cancel out, and you actually end up adding the value. It's a neat little math trick that helps us dial in that final perfect number. And here it is, the whole shebang. The complete formula for a perfectly precise measurement. It's your observed reading, that MSR, plus n times the least count. And from that, you just subtract the 0 error. You master this equation right here, and you have officially mastered the Vernier Caliper. So we started with a really common problem, just trying to measure something that falls between the lines. And we ended up here, with a tool and a technique that can measure with incredible accuracy. This is about so much more than just numbers on a scale. It's about having the power to make things that fit, things that work, things that are, well, perfect. So the only question left is, now that you have this power of precision, what are you going to build?